about, get your notes out. We're going to talk about graphing rational expression, but before that, we're going to go reciprocal.
We don't talk about how to.
Do you need 2 sheets of paper or one?
Why are you asking relevant questions? You need a paper.
That's one camera. I can barely
Okay, so we're going to talk about graphing reciprocal function first. This is a reciprocal function, 1 over x. You already know how to graph 1 over x.
No.
If you don't, we'll review a little bit. So this is a 1 over x graph look like. It looks like what?
2 L's.
2 L's, yes. So it's going to be like this way.
Yeah, like your king logo.
Yes, so you're going to have the first one here. There's going to be an asymptote on the x-axis and y-axis. And the graph's going to be like this. And it's going to go, there's an asymptote right in both. There's a vertical asymptote, there's a horizontal asymptote. And they both, they go in through this point, 1, 1, and negative 1, negative 1.
Okay.
Okay, so what does a negative 1 over x graph look like? So we're going to talk about this one is usually located in first quadrant and third quadrant. 1, this is a quadrant. Second quadrant, they're doing counterclockwise. So that's going to be third quadrant, and this is the fourth quadrant.
Negative.
So 1, 2, 3, 4. So usually it's at 1 and third quadrant. What does y equal to 1 over x negative graph look like?
It's in the second and the fourth quadrant.
2 and 4.
It's going to reflect, right? So it's going to reflect both. So it's going to be this quadrant here. And this is just a general sketch. So there's an asymptote right here, and there's an asymptote right here. So we're going to talk about how do we graph with the transformation. So let's say 1 over x plus 2.
So you graphed it wrong. You graphed it wrong.
Oh, sorry.
I was about to say,
Cool. Thank you, Ben. Okay, so it'll be the second and fourth quadrant. Now, what if we graph y equal to 1 over x plus 2 minus 3? What does that do?
What?
Wouldn't it be a graph?
Just don't. It doesn't work in your brain.
What do you mean?
It doesn't work in yours either.
Down 1 to the left 2. Down 3 to the left.
Okay, so
The asymptote is moving, right? The center of the asymptote is moving
yeah,
in the aspect of transformation. So it's moving left and right first, or up and down first?
left and right.
Left and right first, because that's the inside of parenthesis. Okay, so there's an inside parenthesis right here. So it's moving which direction?
Left
Left 2.
Left 2, okay, so left 2.
And then down 3.
And left 2, and those down 3. 1, 2, 3. And that's going to create a coordinate of where the asymptote intersect. And that asymptote is going to be this way. And the asymptote is going to be this way. Sorry, it's going to be a little bit of both. So, and which quadrant will it be? Well, belong to, if this is the origin,
1 and 3.
it's going to be 1 and 3, thank you. So that's going to be here. Oops. It's going to go in like this. And the graph. Remember, 1 over x is even or odd functions.
1 over x.
It's even or odd function.
Even.
It's odd. Okay, 1 over x is moving like this. So we just kind of recap what we talked about reciprocal function before. Okay, we just talked about those. Yes?
So to get the coordinate, use my
Yeah, so the coordinate of the asymptote is moving. So it's moving left 2 units and down 3 units, 1, 2, 3, and that's gonna be asymptote right here. Now that's just an easy graph, and we're gonna talk about.
Yeah, we're reviewing it.
Okay, so we're gonna talk about the next one that you haven't learned. So this is not a parent graph, but I do want you to know 1 over x squared graph look like. If we say this is our functions, how do we know it's our function? If I just say this is f of x, and then if I say f of x equal to 1 over x, and when f of a negative x is equal to negative x like this, which is negative f of x, so which is, that's the r function. What is this? This is even or odd function?
Even.
Even, because if I get negative x,
Yeah.
it's going to be 1 over x squared. Go back to original position.
Yeah.
So can you predict the graph of 1 over x squared look like?
What do you mean?
What does the graph 1 over x squared look like?
Wouldn't it be like in the first and third quadrant?
The first and third is already same thing, 1 over x.
What would be two?
First quadrant, second quadrant.
First quadrant and second quadrant.
I mean,
Because they're even.
Okay, so they're even functions, so Andres have a good perspective. Is it will be a first and second, so what does the graph look like? So this is a 1 over x graph look like, right?
I'll be like this.
Right. It's gonna flip the negative because it doesn't matter what you plug in, it's never gonna get negative. If you plug in negative value there, it's always positive because you square it. So if you square it, that's gonna reflect to this way. So it becomes 2L that is symmetric to both ends. It's gonna be 1 over x graph. So I call it volcano graph. It looks like graph 1 over x squared. So, so the graph is gonna be like this. So that's gonna be like this.
Oh.
And it's gonna be it's like looking like a mountain graph, but except there's no end to it, just keep on going up.
Oh, so like the second quadrant, third quadrant just flips over.
Yeah, it's gonna flip, so it was like this, and it's, because of negative, it's gonna square, so it's gonna become positive, so it become those two L lines right next to each other, so it's gonna create like this. That's what it make the graph goes. Are we okay here?
Yeah.
So can you tell me what's a y equal to negative 1 over x squared graph look like? Well,
Would it
if
be
it's a positive, right?
uh-huh.
A negative is gonna be what?
Down?
Down, right?
Yeah.
So it's gonna be 2L right next to each other, but it's gonna be down. Am I going too fast?
Not yet.
So, not yet, yes, you're right, because we are gonna get faster. Okay, so that's negative 1 over x graph. So here's what I want you to graph this one. Y equal to negative 1 over x minus 4 parentheses square plus 2. What would this graph look like?
Oh my God, Jesus Christ.
It would be.
It's 4
No, shut
to
up.
the right.
Shut up. 4 to the
Up
right,
to.
down, up to.
guys, that's like I'm trying to pick it.
That's easy. 4 to the right, 1, 2, 3, 4, up to.
Michael is trying to pay better attention.
Me too, but this is.
And then it's flipped.
But he just asked us, what do we think?
I'm trying to pay attention.
I'm
So now, let's look at this. What's inside the parentheses?
Minus 4.
It's moving which direction?
Right.
Right, right?
Mhm.
Yes.
And then up or down?
Up to.
Up to. And there's a negative. What does the negative do here?
It's gonna be an upside down volcano.
Upside down volcano. It looks like a sinkhole. But
with the square?
sorry, I didn't see the square.
we're gonna talk about 1, 2, 3, 4, up to. It's gonna be asymptote. Looks like this. Okay? And then usually if it's not negative 1, it's gonna go up like a mountain, like a volcano. But it's a negative 1, it's gonna flip downward. So it's gonna be like this. And this graph is gonna be end up like this. So Tatiana wasn't here, but 1 over x graph, instead of they both like this, it's gonna reflect because there's no negative here, because it doesn't matter if you plug in negative number, it's gonna square, so it's become positive. So this part of the graph is gonna flip upwards. So it's gonna be like this. If negative 1 over x squared is going to look like downwards. If it's shifting, it looks like this. So now we're okay here?
Yeah.
Okay, so now we're going to talk about a little bit more difficult stuff, which is, this is just reciprocal functions. We haven't got to rational function yet. So rational function, what do they look like? Because rational function has all different things. So you gotta understand what are all those things is. Yes? No, that's not the end, we're just the beginning. This is only the beginning. David, are you paying attention? Or are you reading comics? He's reading comics, right? Oh, he's on Moto. Oh, he's doing, look at Cal, oh, okay. Okay, so now we're gonna go look at this part. No one has to watch. Okay, so we're going to talk about what is a rational expression. Jeffrey, pay attention. I know you're not writing notes right now, and okay, but you got to pay 100% attention here. What is rational expression? Oh, the one over there is reciprocal. But what is another case? Okay, so now this is a case that's interesting though. If I were to graph a rational expression, what do I mean by rational function? So graph rational functions. What is rational functions? A rational function is a polynomial over polynomial. So we're going to start by the easiest polynomial you can think of. The one we graph on a reciprocal function is actually a polynomial over polynomial, but we call it reciprocal. But rational expression is you have polynomial over polynomial. So we're going to start with the one easy one. We're going to graph f(x) is equal to x squared minus 4 over x minus 2. So this one is a little bit different than you can imagine. Okay, so I want you guys to kind of think through a little bit. What would this graph look like before anything? You can use your imagination. It doesn't have to be right. I think a lot of you guys were so afraid of being wrong. Being wrong is a process of being right. It's okay that you give your assumption first. So it's like, math is like scientific. You have to have a hypothesis. And you're trying to prove that hypothesis right. But sometimes it can be wrong. That's how science evolved. Same thing as math. Yes, Jeffrey?
Mister, would you like factor and then like simplify?
Okay, you gotta do what you gotta do. You can think about it. So we're gonna graph x squared minus 2. Okay? X squared minus 4 over x minus 2. And if you kind of graph this one, you're going to see what's going on. You kind of think about, imagine like what the graph look like. It might be surprising for you, but I do think some of you guys do know how to do it. If you think you know what a graph looks like, you can show it to me. Graphing on your paper, not graphing on a desktop. Sarah, can you face the camera to the center part? Okay, does that look in the center?
I don't know. Is it?
Oh, thank God.
Is it looking at the center part?
Yeah.
Okay, so we have the graph here. It's x squared minus 4. I'm going to divide it by my x, right? So if I graph it, it's going to be like this. But I don't want to graph it by x. We want to graph by x, what? Minus 2, good. So now we're gonna show you the graph, -2. What do you think graph look like again?
I got it right. I was.
Okay, so, yes, you were right. I didn't say you were wrong. Okay, so the idea is it becomes a line that is straight, but there's some problem with that line though. There's some issue with that line. Okay, so we're gonna look at what the issue of the line. We're gonna observe that line. And if you guys are focusing or not doing too much work, you can see.
Let's see on how many people are just looking at it.
Okay, so I want you to pay attention. I want you to pay attention to this line as I move across the things, and you see, you're gonna observe when I do any stop, when you see something that's odd. So I'm gonna moving along the line, and hopefully you can see it. Some of you guys cannot see it. Do you see anything different?
No.
No.
Besides after
It's
it's
5 when
zero,
it's
it
up.
goes from negative to positive.
Whoa.
It's 3 when.
Now let's go back again. Do you see anything different?
I see, I just don't know what it is.
Okay, let's move back again. But move it slower. What do you see?
The numbers.
The numbers, there are a couple numbers that are.
7, 3,
6, 5.
Maybe move slower because now we got some.
That's
Still a
more
negative, go over zero.
Is there more to graph here, I think?
No,
Where?
Go up.
Higher, 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 higher. Almost there. Yeah, a little lower.
Warmer.
Yeah.
There you go. Back.
Damn, I think that.
So Benny is the only one that's not good.
that's a lie.
Okay,
Wait, Jaden, you think you're
so it creates a hole. So Daniel, you mind to move that iPad back to the screen there?
This is such fun.
Cameraman.
Fire. Boys.
Cameraman's?
I think he's a man.
Camera boys.
At least I'm better than you at sports, so I get up to.
Okay, so it's okay.
Any better than
So it turns out there's a hole, and we don't call it a hole, we call it, in terms pre-calculus and calculus, we call it something called removable discontinuity. Okay? Removable discontinuity is what's gonna happen here. We're gonna go through the process how to graph this. Okay, we're gonna go through the process how to graph this. So you can grab a whole big graph like this. So we're gonna talk about the first step. The first step is graph rational expression, the process, rational expression. A function, sorry. The first step is make sure you factor everything. Factor the numerator and denominator. And denominator. Okay, factor everything. Factor the top and bottom.
You're welcome.
The second step is actually, you're gonna see some cancel, you go ahead and cancel. Okay, so cancel the factor if you see anything. Cancel the factor if you see fit. So that means they have to have an exact same factor for you to cancel. But the second step a little bit further, because you actually can find the location of that hole. You can actually find the location of that hole. You can find the location of removable discontinuity. So how do I find the location of that location? Of the hole, which is, we don't call it hole, we call it removable. And there's a removable of discontinuity. Okay, removal discontinuity. What are the removal discontinuity? They are whole, exactly. So now how do we do that? You take the cancel factor, you take the cancel factor, equal to 0. Solve it. Okay? Plug in the new equation. New equation. Okay, so we're going to talk about that. So you can write it down. I'll give you some time to write it down. The third step is, if you have a denominator, take the denominator equal to 0. If you have denominator, set denominator equal to 0.
How did you say like if you're literally like so close?
And we're going to call this as a vertical asymptote. And vertical asymptote is also this name called non-removable discontinuity. Okay, so non-removable discontinuity. Yes, Ken?
After removable discontinuity, whatever in the first time, what does that mean afterwards?
Take the cancel factor.
Yeah, what's that?
Take the cancel factor equal to 0. We're going to talk about that. We're going to show you how to work. And then plug into the new equation. The problem is the new equation. So we're going to go do this part. We're going to show you how to do this. Very, very simple. You take the graph this equation, and we say, okay, let's factor the top and bottom. It's going to be x plus 2, and just like Jeffrey says, I can just cancel this. Once you cancel, then you're going to get your new equation. So this is x plus 2. We're going to call this the new equation. Okay, new equation is x plus 2. Now, what happened? We're going to take the cancel factor. We don't throw away. They cancel, that means it goes away. Not only that, when you cancel something, please write 1 next to it, because you don't make mistake if you do that. Then you have x plus 2 over 1. Well, since anything over 1 is going to be x plus 2. That's your new equation. Okay? Because it's going to affect other questions also. Now, what we're going to do is, you're going to graph the new equation, but before that, take the cancel factor. This one is the cancel factor, right? You're going to set it equal to 0. X is equal to 2. Now you're going to, according to that, plug into the new equation. Plug in the 2 into the new equation. So we're going to say f of x is equal to x plus 2. We're going to plug in the 2 in there. It'll be 2 plus 2 is equal to 4. That means 2 and 4 is the whole, which is a removable discontinuity. Okay, so 2, 4. Now you can graph the new functions. So what is new function? X plus 2. We know how to graph that. X plus 2 is going to be 1, 2. What's my slope? It's 1, 1, right? So it's going to go in like here, go in like here. And 2, 4 is going to give me a hole, and it's like this, and like this, and like this. So there's a hole there. It's a straight line, but there's a hole. So this is a 2, 4, right? This 2, 4, this is actually removable discontinuity. Why do they call removable? I don't know if you ever watched this Geico commercial. The Geico commercial is a guy like walking on like a dam, and the dams keep on leaking, and the hole start puncturing out, and there's a guy go fix it. He just like chew a bubble gum and they kind of seal the hole. I don't remember if you remember that. It's like you take a bubble gum and you seal the hole on the dam. So you see it leaking, you chew bubble gum and you start fixing the holes. And that's pretty much what happened. I can put a dump right here. Now it's continuous. Now it's not continuous. So that's why we call it a removable discontinuity, because I can remove with the finger, just press it here, says, oh yeah, now it's continuous.
That's to make you do that.
Okay, so it's gonna be continuous right here, it's not continuous. That's pretty much the idea. So now, I want you to grab this function though. This is a new function I want you to grab. F of x is equal to x minus 2 over x squared minus 4. Do you see what's the difference between those two?
Yeah.
Square doesn't.
You're gonna have a denominator left over.
Okay, so now we want you to grab this one here.
Okay.
David's already gone. Is he gone?
No, not yet.
Is he?
No, that's the nice.
So what happens to the result?
I've never seen that one. Or on my way.
Sir, if you found the x and the y, then how is the y undefinable?
That's a good question. So it's undefined. It's not really undefined. In term right now, it's undefined. But in term of next year, we're going to call this as actually indeterminate. But the reason why it's indeterminate is something that you can use limits to find it. But we haven't get there. Right now, just think about there is a coordinate of the whole. You can actually plug in a new equation, you can actually find the whole. But you don't need to worry about anything else. Okay, you don't need to worry about anything else. Next year, we're going to teach you the reason why there's a hole there and why it's happening over there. Because
You say next year as if like anybody from here minus like 3 people are gonna be in your class.
5.
Hey.
Andres?
Andres will be fine.
Are you gonna?
Marion's gonna be fine. Sarah's gonna be fine.
They're like,
David is already there. He's taking both classes at the same time.
you recommend it?
Yeah, but I feel like that'd be so confusing though, doing both at the same time. 'Cause wouldn't you need to know
You have to
something?
take 2 tests on Friday.
Oh.
You take pre-calc and calc.
I'm so sorry.
Easy. There's something you gotta know.
He's passing both.
Wow.
Do you have like?
Yeah, you need to have good time management.
I'm gonna do AP stats.
You what?
No, I'm gonna do advanced topic.
It's gonna be on live stream. I'll beat the crap out of you.
Yo, turn the cameras.
Basically, we're all done, you can keep going.
No,
I'm not done.
How do I-
It's not even that hard.
I'll give you another minute to look at it.
Yo, you know what else is that hard? Bro, where's the source?
So that's the hard playing your defense.
Oh my god.
You did like a full like illustration of the read stuff.
See,
At least I was
wait, you
running
can
around
send
the
me
door.
like that, but like,
I'm taking a picture.
Now what we're gonna do is we're gonna spend time to factoring this, but we already know the factor because I give you an easy one to factor. So that's gonna be x minus 2 over x minus 2 over x plus 2, right? Now what did I say? Every time you cancel, you have to write what? 1. Because literally last period somebody says, oh yeah, I canceled this. That's gonna give me x plus 2. And that was the wrong answer because that's technically what people make mistake. But if you write 1, then there will be nothing happen like that. So it's gonna be 1 over x plus 2. So that's a new function. So new function is right here. This is a new function. Right? So then you say, okay, well let's take the next step. The next step is take a cancel factor equal to 0. So x is equal to 2, right? What do we do? Plug in those 2 into what? The new functions, right? So we say f of x is equal to 1 over x plus 2. And we plug in new one in there, we can find a whole. So it'll be 2 plus 2. That's equal to 1 over 4. So at 2 is 1 over 4.
I did it.
That's going to be a whole.
uh,
Or removal
That's how
discontinuity.
far I got.
Now, let's take a third step. Take a third step. But I don't need to do a third step. You guys already know what happened. X plus 2 is the asymptotes moving what?
To the right, to the left.
To the left 2. So if I were to take the denominator, new denominator is x plus 2. So x plus 2 is equal to 0. Instead of the other one, I'm going to third step. x is equal to -2. So that means my asymptote is going to be a -2. -2 is going to be an asymptote.
Yeah.
I don't need to do a third step to know the graph is moving left 2 units. But if I do, it's going to be like this way. So now the graph is going to be like this, and then the graph is going to go in graph like this. Sorry, it's going to be like this. And this part is going to be like this. But now at 2 here, there is here a hole here, and that hole is going to be 2 and 1/4. And that's going to be an asymptote. Yes?
With that second part right there, the x plus 2 equals 0.
X plus 2, okay, so that's the third step. If you have a denominator left over, so that's the new denominator, right? It's x plus 2. I'm going to say x plus 2 equal to 0, x equal to -2. But I don't really do that step, but we already know how to graph 1/x plus 2. That means asymptote is shifting left 2 units. But in case if you want to find out why do they shift left 2 units, you can set the denominator equal to 0 and solve for it, x equal to -2. That's how do they move 2 units to the left.
Okay, so we already did, that's just
Yeah.
see the math.
That just see the math, good. So this is the part that you guys understand. Now, we're gonna give you a new one. The new challenge is this. The new challenge is this. The third case is actually, it's a little bit harder. The third case is actually, I want you to graph this function, which is, like I said, there is some teacher that actually teach wrong. I don't know this school, but I know in Dr. Phillips, the teacher teach wrong, so we have to make sure that we don't go into the wrong part. So we're gonna give you this example here, x minus 2 over x squared minus 4x plus 4. So we're gonna show you how to graph this. So you're gonna still follow all 3 steps, and hopefully you're gonna find there is a conflict of interest between a non-removable discontinuity and removable discontinuity. There's conflict of interest, and who's gonna win?
F of x minus 2, x squared, 4 minus 4, blah, blah, blah.
So f of x, this is a new function, and this is a new one I want you to graph. It's f of x equal to x minus 2 over x squared minus 4x plus 4.
Will you just cancel one out?
I had a small mistake in that.
I don't know.
What about like?
Yes.
So the 2 and 1 over.
Oh, that graph, why is it only moving over 2?
Why is whole in 2 and 1/4? Because you take a tensor factor.
No, I know that part, I'm asking like for the whole, like, the moving of the graph, why did it only go over 2? You can only look at
Oh, because this one's 1 over x plus 2, right?
Oh, that's the function we're using.
Yeah, that's the function we graph. We go to graph the new function after we simplify.
Oh,
So it's
but
moving.
isn't like the conflict because your memory is gonna be 0 and you plug in the,
So there's a conflict here.
yeah.
So in this case, the conflict of interest, who's gonna win? So you got a badass, and you got a super badass. Okay, so, I don't know if I can say that on live stream. Wow, well.
Gets demonetized.
So, depending on who's gonna win now in this case. So we're gonna talk about that, and we're gonna go into this process. If we go through this process, it should come out to be okay. Okay, so, so you guys understand the first 2 cases, right?
Yeah. Ish.
Yeah.
I just messed up on one part of the whole, and that threw me off. That's that is a fraction.
So we're gonna go through this, we're gonna go graph the last case. The last case is gonna be f of x. What's my first step? Factor everything, and we already know how to factor this, hopefully. If you don't, then you're gonna use the box method. Then that's gonna be x minus 2,
X plus 2, yeah, x minus 2 squared.
x minus 2 times x minus 2.
Yeah, same thing.
So once we're gonna cancel out, that's 1. That's 1 over x minus 2. So that's my graph. But we're gonna take the cancel factor. We're gonna do the step number 2, right? X minus 2 equal to 0.
X equals 2.
2. Now we'll plug in a new equation. What'll happen?
So 2 minus 2 is 0.
1 over 2 minus 2 is equal to 1 over 0.
Which equals to 1.
Undefined.
No, you can't have a.
Shut up, okay?
You're welcome.
Well, it's gonna have one undefined. So they use that way. That's interesting. That's not gonna give me a point. But there's a reason why I didn't give you a point, because if I take a dir step, the dir step is taking denominator equal to 0. Denominator equal to 0 is gonna give me undefined, right? It's gonna give you a vertical asymptote. So x equal to 2. So x equal to 2, that's gonna be like this. So 1, 2, that's gonna be asymptote. And some people is gonna ask, what is asymptote? Asymptote is like one of the things that you cannot touch. Like you get so close to it, but you cannot touch. Okay? So now the graph is gonna be 1 over x minus 2, so that's gonna be in this quadrant. And this one's gonna be in this quadrant. And then you say, where's the hole? Well, if I plug in 2 into here as undefined, there is no hole. Okay. Because asymptote is the bigger badass. Or asymptote.
So pretty much Andrew.
Okay, so it's the bigger thing. So you have to let the big asymptote take over. There was no hole in this case. Asymptote is the biggest thing here. So there was one thing trump another one, which is asymptote trump the removal discontinuity. Non-removal discontinuity is also called vertical asymptote. So those are the things that you need to pay attention to. You understand?
Yes, sir.
So asymptote is overwrite the whole, or trump the whole. Okay, so that's the idea. So I have some more times where I want to build some foundation for tomorrow. Tomorrow is we're going to talk about not only vertical asymptote, we're going to talk about how do they behave at asymptote. So, yes.
So the final answer is 1, 0.
The final answer is the graph look like this.
Okay, so
There is no holes.
So the
Can you
homework's
post
all
them
gonna be graphs?
Huh?
The homework's gonna be all graphs?
The homework is gonna be, I'll give you the steps, says, hey, can you find me location of the hole? Can you find me this? Can you find me that?
Are we gonna need to graph?
Yes. Okay, so shh, I'm not done yet. Okay, go ahead, you can grab stuff, but I'm not done yet.
I have a question. Can you like put the homework out really early today? Okay, thank you. Like right after school. Thank you.
Okay, so it's not hard, today's homework is not hard. So it's gonna give you 3 different cases, ask you to graph. Also, there's something, how do they behave at vertical asymptote is what we're gonna talk about. And also, how is horizontal asymptote come in play? Horizontal asymptote is gonna come in play in a second. Now, there are a lot of kind of asymptote. There are vertical asymptote, is the biggest and baddest of them all. Okay, this is the big, if you have vertical asymptote that overrides everything. Horizontal asymptote is sometimes you can touch the horizontal asymptote. Okay, so, and we're gonna talk about why we can touch a horizontal asymptote. There's also the asymptote look at like a slant asymptote. The slant asymptote is you're gonna go with a slanted line, and for the people that who's going to high level math, that we're not talking about, we're talking about beyond AP calculus. Maybe 1 or 2 of you guys gonna go beyond AP calculus. They are actually asymptote look like a parabola. Okay, they are asymptote look like a waterfall. They are asymptote look like a lot of different things. So we're gonna call it 2nd degree asymptote, the 3rd degree asymptote. They are asymptote look like that. But that's another topic for another day. We're not gonna get to that.
What's after pre or like AP calculus, like what comes after that?
So in college,
There's like A and B.
and in college, in high school we have a AB AP calculus, and we have BC AP calculus. That's what high school can offer. In college, we don't call it A, B, or B, C. In college, we're gonna call it Calc 1, Calc 2, Calc 3. So there's 3 different calculus that you can take. If you're on engineer track, then you're gonna have to take Calc 1, Calc 2, Calc 3,
There's so many math.
and then one more class called differential equation.
Yeah.
And after that, you should be enough to cover all the math for engineer. So if you depend what kind of engineer, if you're a computer engineer, then you have to take another class called linear algebra, and you're gonna have to take a class called logic. So that's pretty much all the math class there is. But there are, if you're a math major, there's like 20 different math classes there is. I still have some time, right?
I don't know.
You have 10
Oh,
minutes.
you're like
We have
6
like 9.
We have a lot of time, so we're gonna talk about what the other ideas.
Is this tomorrow's lesson?
Yeah, but we had to build a foundation for that.
We can talk about it, I'm not thinking of.
No, you are taking notes.
We need those.
Yes.
Okay, but so you, if you have
And you're gonna ask
now,
so many
you'll be
questions.
strict.
I'm gonna actually add over 20.
Exactly. You can.
I said
I did
okay,
only
and I'm
20, makes
smart.
sense. Anybody have some?
So let's talk about what if is the idea of infinite. Infinite. So infinite is a very, very big number. It's a thinking that is. For example, if I have infinite amount of money, that means doesn't matter how I spend, I'm always gonna have money. So for things like this, a Bill Gates can have a lot of money. You know, there's something called opportunity cost. A lot of you guys don't understand this. Opportunity cost is like a lot of you guys. You guys choose not to focus in this class, and you guys don't know what is offered out there. So here's the thing. Bill Gates, I'm giving you an example. Bill Gates see $100 on the floor. If he bent down to pick up the $100 and pick it up and put it in his pocket and then walk away, he actually lose more money.
Even for middle class credit. No.
He can walk by that $100. He can walk by that $100 and just go do his own thing. Or like Jeff Bezos or Steve Jobs, they all the same thing. If they bend down to pick up the money, you actually waste time, and that time they could have made more money on that. So in that 10 seconds they bend down to pick up the money, you can make it thousands because they can walk by and do another project and make it billions of dollars.
You know what's crazy about that? That's like $1 to them. Like,
It's not even $1 to them. It's like a very, very minimum, it's like cents to them.
They were showing how much Michael Jordan makes, like per second, per minute, and then they show like at the end.
What does he do?
Michael Jordan, if he lived his life like 50 times, he would still not be as rich as Bill Gates.
Yeah.
Yeah. That's crazy.
So this is pretty crazy, right? It's a pretty crazy idea. So a lot of people says, okay, they want to work in high school and they want to work in high school and they want to get a job for $10 an hour. So what you don't understand is if you get a good education, if you make $10 an hour, great. After tax, after everything, you can work so many hours. That's you assume that you work full time. So $10 an hour. So you assume you work full time. You're gonna get $8 net in. And that's what I'm trying to explain to Bendy a long time ago. Is this that if you work, you actually losing out a bigger money, the bigger part of money. So for example, if you got for that bright future, that's probably $38,000. I don't know how much is it. It's probably $38,000. Let's just assume that's $38,000. Let's imagine how many hours you have to work for that $38,000. Well, $8 an hour, right? $8 an hour, right? So $8 an hour. So if you work, let's just say 100 hours, so it's gonna be 8,000, right?
Every week.
No, 1,000 hours. Let's work 1,000 hours. It's gonna be 8,000.
Every what? Every month.
No, let's just say work 1,000 hours. So let's say we say 40,000. So that means you have to work 5,000 hours. 5,000 hours is equivalent to what? Well, 5,000. Let's just say if you work 40 hours a week, and you have 52 weeks, right? That's what? 40 times 52, that's roughly 2,000 hours. That means you had to work 4 straight years, 4 times, where you could have focused on schoolwork, they actually give you the same amount of money. Because why? Also that, you guys don't think about mathematically. That you can work 4 times, instead of, you could have worked 4 times, you could have worked same thing on a school. And we're not asking you to work 40 hours on school. No, we just ask you to go to school. You had to go to school anyway. It's just the amount of work you had to put in on the homework. So if you do that religiously, right, and you increase your SAT score to a certain thing, and most of the people in this school are free and reduced lunch. So that means what? You got scholarship that pay for your tuitions, which is 30,000, 30-some thousand. Also financial aid. You can use that financial aid to buy a car, buy a clothes, buy a new iPhone, buy all the things. My cousin did it, my nephew did it, and that's the things that you guys kind of overlook. Stop talking. This is very, very important for a lot of you guys. You guys don't think about everything in math. Most of the math that's going to impact to you directly, where you choose to not focus on the high school, you waste your time, you waste your life, you prefer to watch Netflix, you prefer to play Fortnite, you prefer to do other things except homework. And guess what? Those homework can offer you money that you don't even know. It's invisible. But you choose to do everything else that doesn't make you money. That's a lot of things that you guys don't consider. You choose to do drugs. You waste money. Okay, so it's not funny. It's not funny. It is not funny. But you guys gotta make your life straight. Choose to do the right thing. You are making money, you don't even know it. Yes. So Bill Gates has a lot of money. So it doesn't matter if I borrow Bill Gates for $2. No, it's like that's like 0.002 cents for them. So we're gonna talk about infinity subtract 2. We're gonna assume that Bill Gates has money, infinity subtract 2. But we're gonna talk about when a 2 is negligible. What do I mean by negligible? It doesn't even hurt him, even a bit. If you take $2, it's like, Bill Gates, let me borrow $2. Bill Gates is like, he doesn't even want to answer you because it wastes his time to answer you.
He doesn't carry dollars.
Yeah, he probably doesn't even carry $2. He has so much money, he doesn't even carry $2. So, that $2 is insignificant. The $2 is insignificant. So, this one, we can talk about it. It's not important. We only care about infinity because the $2 is insignificant. Let's compare infinity squared versus infinity. We're going to talk about it tomorrow.